So there's 0 on the far right, as we put it. And then we said on the top, we'll have 90.
90. Yes.
90. And then 180, right?
Yes.
And then 270. And then back here would be 360. Okay. So in this quadrant, what goes in this quadrant?
Which one? In the 90 and the 360? Well, 90 and 0. All.
Yeah, this quadrant one here. Because what I mean is here there is 90 minus. Right?
Yes.
Yeah, because we are talking about going anti-clockwise 90 degrees, and then for you to land in this first quadrant, you need to go 90 degrees and then come back. Okay. This is the quadrant 90 minus. So what is this quadrant now?
That's the sign quadrant. The sign is positive.
So since we put 90 minus here, what do we put in this one?
90 plus.
Yes, 100%. And then we also put what else in this quadrant? We put 90 plus, and then we also put what?
180, but I can't remember if it's wait, it's minus. It's minus, yes.
180 minus, right? Because if you're going to go 180 degrees, and then you minus, so you end up in this quadrant. Okay. And then in the quadrant where T is, what do we put there?
180 plus.
180 plus. And then in this quadrant, what do we put?
360. Minus
360 degrees and then minus. Perfect. So all you have to remember is that only when you're dealing with the 90, that's the only time when your trigonometry ratios change from sine to cos and then vice versa. That's the only time. Let's not worry about the 90s for now. Let's deal with the 180 and the 360 for now. So if I write down sine 180 degrees minus theta, like this, what is this going to be equal to?
positive sign.
Pardon? Positive
Theta.
sign, right?
Sine theta. Yes, theta.
Positive sine theta. And why is it positive sine theta?
Because it's in the quadrant where it is positive.
100%. Because the 180 minus falls in the quadrant where sine is positive. So what if we had cos 180 minus theta? What would this equate to?
Minus cos theta.
Minus cos theta. And why is it minus cos theta?
Because only sine is positive in that quadrant, not cos.
100%. Okay. And then what about this one?
Minus tan theta.
Minus tan theta. Because tan is negative in this quadrant, right? And then what about this one?
It's still minus cos.
Minus cos theta. Okay. And what about this one?
Positive tan.
And then why is it positive 10?
Because tan is the only one that is positive between 180 and 270.
Yeah. And then last T.
Negative sine theta.
There we go. You see, as long as you're dealing with 180, whether you're plus or minus, these stay the same. It's sine and sine, cos and cos, tan and tan, cos and cos. moment you start with 90, you only work with cos or sine. So if you have sine 90 minus theta, what is this one going to be?
I'm not supposed to switch over to cos because when it's the 90, they're supposed
Okay.
to change.
Okay. And then
Oh,
is it a
they're
plus or
positive.
minus?
See, that's that's the one that loses me. Ah, positive. It's okay.
Positive, because the A tells us all of them are positive. That's why this is a positive. What about this one?
It's positive sign.
Positive sign. Perfect. And then what about this one?
Minus cos theta?
So we're dealing with sine, right?
Yes.
Let me leave this one blank for now. What about this one?
Positive sign. Because on the
So
other
you
side,
said,
yeah.
so you're saying this one is positive.
Well, no, because cos isn't
And
positive in the second quadrant, and that's where
yeah,
90 plus theta.
this one has to be a minus, because whenever you choose the sign, whenever you choose whether it's going to be a plus or minus, you always use where you're coming from. So the sign in this quadrant is a plus. So here you're going to put positive cos theta. But then a cos in this quadrant is a minus. So you're going to put a minus here and then sine theta. So you do change them, but then you choose the sign based on where you're coming from. You see it. Does that make sense?
Could you explain it to me again?
So sine is a positive in that quadrant. Cos
Yeah,
is a negative
it's a
in the
negative.
quadrant. Yeah. Because you see in this quadrant,
Oh,
90 plus, only sine is a positive. So because you're dealing with sine here, that's why this has to be a plus. At the moment you're dealing with cos here, this has to be a minus. This is changing
minus.
because of the
Okay.
90. But then you choose the sign that goes here based on where you're coming from. You see it? Does that make sense?
Yeah, it makes sense.
Perfect. So with what you may call, with what we have just done now, you see, if we were to look at 360, let's use 360. Let's say here, cos. So you see with 90, you can see we're only using sine and cos, because with 90 and then 10, you don't necessarily have to worry about that. You see. But if you do want to know, if you think of it right, 10, let's say 90 minus theta. Logically speaking, this is equal to sine 90 minus theta over cos 90 minus theta. And then logically speaking, this is cos theta. Logically speaking, this is sine theta. You see, but this is not something you need to worry too much about. But for interest sake, now you know. Because remember, sine, remember 10 can be written as sine over cos. You see. And whatever is here is going to be there and there. Does it make sense?
Yes, it makes sense.
Great, great. So, with all that being said, right? This is the idea. If you were to now deal with 360, whether it's here you can also get 360 plus in this part. If you're dealing with sine 360 minus, what is this going to be equal to?
Oh, cos theta.
Where we're dealing with
Wait, no,
360.
wait. 60. I
So
don't
remember,
know.
what did we say when we put down this purple block?
What?
Like we said, these were to show that we only change from sine to cos when we deal with 90, right?
Yes.
Yeah. So since we're now dealing with 360, if you have 360 minus theta here, what is this going to be equal to? Does it change to a cos, or it's still going to be a sine?
It's still going to be a sine.
Yeah. And then is it a plus or a minus?
Minus.
A minus. And why is it a minus?
Because only cos is positive between
this.
0 and 2. Well, 360 and 270. Yeah.
Yeah. You see. So that's why you put a minus here. So if you have 10, 360 minus theta, what is this one going to be equal to?
Minus 10 theta.
Minus 10 theta. And then this one,
Positive cos theta.
yeah. You see. So what about the pluses now? So say we have 10, 360 plus theta. What is this one going to be equal to?
Still minus. Oh, snap. Positive.
Yeah, because in the first quadrant, everything is a positive. And then, what about this?
Positive.
And then,
Positive.
great. So, seems like the reduction formula is not a problem. So look at all these things. It's all the formulas that you don't have to cram, because you can just write them out and see, okay, this is 180 minus, 180 minus is here, so only sign is a positive. You'll be able to write down all your answers here all the time. Look at all of these. You see how many there are, but you don't have to cram any of them, because you can just write anything randomly and already know what it is. So if you pick anyone random here, like let's say here sine 90 plus theta, what is this one equal to?
Oh yeah, I'm finally getting it. Sine 90 theta. It's positive cos.
Positive cos, you see, because in the class diagram, 90 plus is here, of which in this quadrant, sine is a positive. And since you're dealing with 90, this has to change. And since you're dealing with sine here, this has to be a plus, because sine is a positive in that quadrant. You see, it's just like that. You see, anything random that is thrown at you, you'll always be able to work it out. What is this one equal to?
That is positive sine.
Positive sine. So we could go on forever. There's no need, because that's how the reduction formula works. So in addition to this, right, you need to now be familiar with negative angle. Negative angle. Negative angles are easy because there's just one exception, and that's cos. What I mean is this: cos with a negative value here is the same as cos with a positive. This is the only one where if there's a minus here, it's equal to if there's a plus. That's the only one. The reason why that's the case is because a cos graph is symmetrical, a standard cos graph. is symmetrical about the y-axis. What I mean by it's symmetrical about the y-axis is that on the one side of the graph, it will look like this. On the other side of the graph, it will look like this. So if you consider negative values about the x-axis or positive x values about the x-axis, it's just going to be the same thing. You see, because something like what you may call positive cos 180, right, is equal to this would be like minus 1. You see, but then cos minus 180 is also equal to minus 1. You see, that's just an example to say only for cos are you able to have a negative here or a plus here, and it will give you the same value. There's the proof. You see, cos negative 180 is a negative 1. Cos 180 is a positive. I mean, it's also a negative 1. You see it.
I see it.
Yeah. So when we speak of negative angles, we're trying to say anytime there's a negative here, right, it is equal to positive cos. However, for the other two, which is sine and cos, which is sine and tan, I mean, those ones, if you have sine with a negative value in here, it will always be equal to negative sine theta. Okay. Same with tan. Tan with a negative here will be equal to negative 10, like that. You see, that's for sine and the tan. But then for the cos, as we said, it's only cos where if you have a minus here, it won't affect this. You see. For the others, they will get affected. The minus here means there's a minus out there. The minus here means there's a minus out there. But a minus here does not mean there's a minus there. Does that make sense?
That makes sense.
Yeah. So the reason I'm showing you this is because when you will be breaking stuff down, remember there are cases where they'll give sine things like sine, and then they'll maybe put theta minus 180. For you to deal with this, what you need to make use of is the fact that, remember, this here is more or less in the place of what you may call where this entire thing could possibly be. But let's not overcomplicate. Let's just start from here. If you want to see what this is equal to, the first thing you want to do is, because you see the 180 and the theta are more like swapped around, what you can do is you can just write them in the way that looks more normal. So the 180, you can put that first with its sign, and then the theta, you can put that with its plus, because this is technically a plus, this is a minus. You see that? We just swap them around. You see?
I see.
Yeah. So because we want to break this up using like our cast diagram, what you can do for yourself is that, remember, in our cast diagram, we are used to seeing things like positive 180 minus theta, and then positive 180 plus theta, correct?
Yeah.
Yeah. So this minus 180 is making life a bit difficult for us. So what you would do in this situation is, in here, in this bracket here, you would take out a minus. So you'll have sine. If you take out a minus here you'd have a positive 180, and then here you'd have a minus 180. You see it?
I see it.
Yeah. So remember, our law says if you have sine with any angle, if it's a minus an angle, this is equal to minus sine, whatever that angle is. I'm just using x as a placeholder because I'm trying to highlight the fact that, you see, if you have a minus in your bracket, right, you can write it out there, and then whatever this is can remain, so that you can use it for whatever you may want to use it for. So this kind of scenario, we low-key have that happening here. You see, there's this here, there's this whole thing here in bracket. This, you can almost consider it as this part. And then the minus here almost is represented by this minus over there. And then the rest of the thing is basically this. So what I'm trying to say is, for you to break this up, this negative symbol, you can write it outside there. So you can have there the minus outside. Let me just put a couple first. I'm gonna color code it so it's a bit more understandable. So this, you can make it equal to minus, and then the sign, and then inside the bracket we can put the 180 minus theta. 180 minus theta. So this minus sign that was here, we just wrote it outside, because when we deal with sine and the negative angle, if there's an angle, if there's a value, if there's a negative there, we can just write it outside. You see.
I see.
Yeah. So from the top, right, we said if you're breaking down an expression and you're given something like this, you see, theta minus 180. This, you may not be able to use the cast diagram to help you break it up nicely. You know, you actually could, because what I actually, another method I use um to like break, I'll show that just now, and then you'll see. So we say it here, because this is not like 180 minus or 180 plus, it may look a bit strange to work with. So what you can do is you can write these two swapped around. It will look like this. You see, 180, negative 180 is in front, the theta here is there. Does this step make sense?
Yes, it makes sense.
Yeah. And then we say, since we're trying to simplify this, the next step, we can take out a minus as a common factor. So if you take out a minus here and you take out a minus there, minus is outside here, right? And then what's left in these brackets, you're gonna put a plus 180, and then a minus 180, and then a minus theta. Does this step make sense?
Yes, it makes sense.
Yeah. So we said this here, right, has a minus symbol there. So this minus symbol, we can write it outside based on this law. See, if there's something here with a minus, that minus, you can write it outside. You see it?
I see it.
Yeah. So that's all we did here. You see, this minus here, we wrote it outside, which is how we have this. If there was a minus here, we wrote it outside. Because this whole big thing here is just a placeholder to say, as long as there's an angle here and there's a minus there, this minus, you can write it outside. You see?
Oh God.
Does that
I
make
see
sense?
it.
Yeah.
Yeah. No, it makes sense.
Yeah. And then, so with that being done, right, it will be easier for you to deal with this thing here. Because if you're seeing here minus sine 180 minus theta, now you have something you're familiar with. Because remember,
Yeah.
we know what this can come out as. You see, this minus is just there. So this is going to be equal to this minus here, right? It's just there. But then, whatever this is, we're going to write it in there. Okay, because I mean, like, this minus is already there by default. So this minus here is this minus over there. But then sine 180 minus theta, we know what that can come out as because of our cast diagram. If you use our cast diagram, 180 minus theta is in this quadrant. Is that true?
That's correct.
Yeah. So, and sine is a positive in this quadrant, right? So here you would put sine theta. You see. So it's showing you that minus sine 180 minus theta is going to be equal to minus sine theta, because this minus here is just this minus there. And then whatever 180 minus theta is, it's going to be equal to sine theta. Does that make sense?
Yes, that made perfect sense. That's actually a nice breakdown.
Okay, so it shows when you get stuff like this, you can just break it down nicely for yourself and then get your answer. The other way you can look at it is if you find stuff like this, right? 180 minus, I mean, theta minus 180. What I normally do is, if you swap these around, right? Negative 180 plus theta. What you can now do is, if you want to use your cast diagram, you have to remember that with your cast diagram, anytime we minus, we actually always go clockwise. Anytime we plus, we go anti-clockwise. An example is, if you look at our diagram up here, remember we said this quadrant here, you would say 180. Remember 180 is a positive number, right? So you're going anti-clockwise 180 degrees. And then when you minus theta, you go clockwise. That's how you end up in this quadrant. You see, if you were to do that for, let's say, the 180 plus, since the 180 is a plus, you're going anti-clockwise 180 degrees. When you plus again, you keep going in that anti-clockwise direction. That's how you end up here. You see, so that's for us to show that. Can you see every time you're plussing, you're just going anti-clockwise. If you're plussing again, you're still going anti-clockwise. But a scenario where you, for example, go anti-clockwise and then have to go clockwise again, it's a scenario where you have something where you're plussing and then something where you're minusing. So an example of that is actually this, right? If you go 180, you're gonna go 180 degrees like that. And then if you minus the theta, you go back, you see. So anytime you were plussing, you see it's anti-clockwise. But then the moment you are minusing, it's in the clockwise direction. So the reason I'm mentioning this is, if you now see stuff like what we have at the bottom here, negative 180 plus theta, the negative tells you you have to go clockwise first. So if you go minus 180, you're gonna go minus 180, you see? And the moment you plus theta, you have to go in the anti-clockwise direction, meaning you end up in this quadrant where only 10 is a positive. So that's how you will know that, okay, this here is just gonna be a negative sine theta. Because in this quadrant, 10 is a positive, and since you're dealing with 180, you will still just have your sine over there. So it's the same idea. All this here still gives you minus sine theta, and then just knowing this here also gives you a minus sine theta. You see that?
I see that.
Yeah. So we can have another example, right? If you had, let's use cos theta minus 180. These two, you can just write them swapped around. So you can have the cos minus 180 plus theta. And then we say you just have to be careful. With your cast diagram, all you have to do is, if you have to go minus, going with the minus first means you have to go clockwise. That's like negative 180, right? You're gonna go negative 180 degrees. The moment you have to plus, you have to come back, which will land you in this quadrant where only 10 is a positive. So this whole thing here is just going to be equal to minus cos theta. You see it?
I definitely see it. I think I'm gonna enjoy this. It's just gonna need some time to get used to this section. Because like I said, I remember I do recall somewhat enjoying some parts of trig in high school. I think you just need like a slow warm up.
I hear you. I hear you. I hear you. You see? So the last one would obviously be, even if it was 10, we would still do the same thing and end up with a positive 10 though, because in that quadrant 10 is a plus. But then if you had even, let's say, 10 minus theta plus 360. Let's do minus theta plus 360. In a situation like this, all you have to do is, as long as you have your cast diagram, this is why the cast diagram is important, because it makes your life a bit easier. So if you're dealing with something like this, you can write these swapped around. You see, n minus, you can have 360 first, minus theta. And then before you know it, it looks normal, you know, because 360 minus theta is just 360 degrees and then minus theta, which is this quadrant. Do you see it?
We do. We
You
definitely
see it,
see it.
right? Mm.
Yep.
Yeah, of which this is just going to give you a negative 10 theta. So in as much as they may have given it like this, the moment you just swap them around, if you're lucky enough, it just looks like what you are used to. So if you maybe then had cases where maybe it's like minus and another minus, say you have 10, and then you have minus theta here, and then minus 360. In a situation like this, your cast diagram will still help you. The reason your cast diagram will help you is because remember, all you have to know is if you're working with a minus, you have to be going um, anti-clockwise. You have to be going clockwise. So if you swap this around, you're gonna have here 10, negative 360, and then negative theta. You see. So with a situation like that, and if you minus again,
Yeah.
you end up in this quadrant where only cos is a plus. So this will give you minus 10 theta. You see it?
Yes, I see it.
So this is minus 360 and then minus theta again. So the other one here, we had said this was minus 180 and then this was plus theta. In this other one, we had said this was minus 180 and then plus theta. You see, that's how it works. When you're minusing, it's clockwise. When you're plusing, it's anti-clockwise. So we could even do these forever also. So if you had, let's say, sine negative theta, negative 180, doesn't matter. You can see all I'm doing first is writing down the cast diagram, drawing it out. CAST. If you swap these around, then I have negative 180 and then negative theta. And then we said, if you're doing with the minus, it's going clockwise. So that's going to be minus 180. And then if you keep minusing, it's going to be minus theta, which is landing you in this quadrant where sine is a positive. So this, it's going to be equal to a positive sine theta. If you had, let's say you had sine theta minus 180. I think we did this one first.
Yeah, I think so. In somewhere at the beginning.
But I just want to show the thing. Yeah, we did this. So let's do with cos then. So if we have
Okay.
so if we do with cos, did we do it with cos? I think we didn't. But it doesn't matter. Since if this is a cos, it doesn't change anything. All we have to remember is if you swap this around, you're gonna have minus 180, then you're gonna have a plus theta. Now in your cast diagram, dealing with the minus means you have to go clockwise first. So that's minus 180. And then the moment you plus, means you have to go clockwise. And then you'll end up in that quadrant where only 10 is a positive because this is CAST. So because only 10 is a positive in this quadrant, this should land you with negative cos theta. Are we on the same page?
We're on the same page, yes.
All right. That is the way we like it. That is the way we like it. That is the way we like it. So that's literally how negative angles work. That's how the reduction formula works. Everything we've done here is all you need to know. about the reduction formulae and negative angles. And remember, all this works when you will now be breaking down trigonometry expressions. You see, is that good?
Yeah, that makes perfect sense. I like the link for this. I actually think